Now, to solve for the molar mass or molecular weight of a gas, an unknown gas, you would have to use this equation right here. It's very clear. However, again, sometimes density is not given to you as D equals this much. You would have to, again, to do the mass over the volume, like in this question. So let's read this question. It says an unknown gas has a mass of 2.889 grams. So that's the mass of the gas. We write it right here. So M equals 2.889 grams. And the volume of 936 milliliters. Now, remember, we talked about mils. We don't want it in mils. We want it in liters. So we divide by 1,000, or that's 0.936 liters. Remember, we divide by 1,000. So we have the volume and the mass. So we can calculate the density right now, or we can actually plug it into the equation. Let's do it now. So density equals mass over volume. That's 8.889 grams divided by 0.936 liters. And if you do this calculation, you would get 3.09 grams per liter. So that's my density right here. Now all I have to do is solve for the molar mass. And the equation goes like this, dRT over P. So the density is given already. It's 3.09 grams per liter. We know what R is. R is a constant. It's always given. You just have to look it up. It would be 0.0821 liters ATM per mole K. Now temperature right here, temperature. So T is, remember, we have to add 273 to it. So 31 plus 273, that's 304 Kelvin. And that goes right here, 304 Kelvin. Divided by pressure, which is 0.967 ATM. Very well. So when you multiply all these out, and notice how start canceling units, you should be able to cancel out the units except the ones that are matching the molar mass units, which are grams per mole. So this gives me about 79.8 grams per mole. Now, I hope you're able to see how the units cancel out. So ATM cancels out. Kelvin cancels out. Liters cancels out. You're left with grams per mole right here. Now, how do you identify this? Okay. You have to be very careful when you identify this. You cannot just simply go to the periodic table and pick out the one that matches it. It can only if it's a gas. This must be, okay? This must be a gas. So the idea here is the following. Can't pick a metal. So you have to know your sections in the periodic table. Can't pick a metal for this. You can't pick any non-metal kit. It might be a liquid. And you have to remember your diatomics, okay? All right, so let me show you what I mean. Let's go through this together. So I go to the periodic table and I'm like happy and ready to go and say, okay, this is going to be bromine right here. But that's incorrect. The reason why is because bromine is a diatomic, exists as Br2. So bromine as a gas would be heavier, it would be twice as heavy. So that would be 79.90 times 2. So it couldn't be bromine. Plus, bromine is actually a liquid. So I'll tell you what are the gases generally. Generally, the gases are right here. These are the gases. And of course, the noble gases. Of course, the noble gases as well. But generally, like those are the ones. But remember, these are all diatomics as well. So if you get something like a 32, you can't just say it's sulfur. It's most likely O2. All right. How do you do that? So let's say we're given these choices. SO2, NO2, CO2, and then SO3. Now, again, I'm going to quickly write down the molar masses. I cannot, again, by now we should know how to calculate the molar masses. So the molar mass of SO2, again, that would be, you know, an oxygen. You have 2 oxygens and a sulfur. This is the molar mass of sulfur, 32, plus you have 32 because you have 2 oxygen atoms. Each is 16. So that would give you around 64. Our unknown molar mass is a 79.8. So notice how it's not this one. NO2, that would be a 14 plus 32 for oxygen. So that would come out to be 46. Okay, this one too does not match. It's too small. CO2 is 12 plus 32. So that's 44. Also does not match. Let's look at SO3, 32 plus 3 oxygens. This comes out to be 48. Remember, each oxygen is 16. Each oxygen is 16 here. 3 oxygens equals 3 times 16, which is 48. So if you do this, you get actually 80.07. Of course, there's always an error, so it's most likely that this is going to be your unknown gas. It's SO, mainly SO3. So again, make sure you calculate the correct molar mass. Make sure you remember that you're aiming for gases. You cannot, in this lecture, unless it's a very, very, very extremely high temperature, go for a metal. This is not a gas. This is a metal. It's a solid at room temperature. So be aware of that.